Welcome to my 7th class on Complex Variable 1. In this lecture video, we will be discussing problems based on type 4. This type 4 consisting of some miscellaneous problems. Problem number 1. Find the analytic function f of z is equal to u plus iv given u minus v is equal to e power x cos y minus sin y. So here the function has been given in the form of u minus v is equal to e power x cos y minus sin y. So from this function we are supposed to estimate the function f of z. Now we will see how to find that. So first take the given equation u minus v is equal to e power x into cos y minus sin y. The first step, I am going to differentiate the above expression with respect to x partially, treating y constant. So if I differentiate this equation, I'll be getting dou u by dou x minus dou v by dou x since u and v are functions of x and y. Now I'm keeping cos y minus sin y as a constant as it is. Differentiating e power x, I got e power x only. So I got the expression like ux minus vx is equal to e power x cos y minus sin y. I'll be calling this as equation number 1. Similarly, differentiating the same expression with respect to y partially, treating x constant. So I will get dou u by dou y minus dou v by dou y is equal to e power x into cos y minus sin y. So this cos y will become actually what? This cos y will become minus sin y and sin y will become cos y. So the expression will be of the form uy minus vy is equal to, since here e power x is a constant, I'll be keeping e power x as it is. So differentiating cos y, I got minus sin y, and sin y I got cos y. So now here we are having ux and vx, and here we are having uy and vy. But actually I'm going to use the formula f dash of z is equal to ux plus ivx. So for that purpose, I need the expression only in the form of ux and vx only. So I'll be changing this uy and vy in terms of ux and vx by using CR equations. So using CR equation for the LHS of the above expression, I'm going to replace uy is equal to minus vx and vy is equal to ux. So it will become minus vx and ux. So I got expression like minus vx minus ux is equal to e power x minus of sin y minus cos y. So I can take minus common factor from here and here. I can cancel that. So I got the expression like ux plus vx is equal to e power x sin y plus cos y. Now I'm going to solve the equation number 1 and the equation number 2 to get the value of ux and vx. The first step, I'm going to add ux, this equation number 1 and equation number 2. So adding 1 and 2, I can cancel vx and vx. I can cancel e power x sin y and e power x sin y. So I'll be having 2 e power x cos y, 2 is equal to 2 ux. 2 gets cancelled. I'll be having ux is equal to e power x cos y. Similarly, if I subtract these two equations, this equation with this equation, I'll be having minus 2 vx is equal to minus 2 e power x sin y. Minus 2 gets cancelled. I'll be having vx is equal to e power x sin y. So I got the values of ux and vx. So as I told, like I'm adding 1 and 2, I got ux is equal to e power x cos y. Subtracting 1 and 2, I got vx is equal to e power x sin y. So now I can make use of this formula, that is f dash of z is equal to ux plus ivx. So I got the expression like e power x cos y plus I into e power x sin y. I can take e power x common factor. I'll be having cos y plus I sin y. It got e power x into e power iy. So it will become e power x plus iy is equal to e power z. So I got f dash of z is equal to e power z. On integrating f dash of z, I got f of z is equal to e power z plus e. And we can do in another form also. By replacing x is equal to z and y is equal to 0, we can do. If I put x is equal to, I'll get e power z cos 0 plus I into e power z sin 0. Sin 0 will become 1. So 0, cos 0 will become 1. So I'll be getting f dash of z is equal to e power z. The answer will be same in both the cases. Problem number 2. If f of z is equal to u plus iv is analytic, find f of z if u minus v is equal to x minus y into x square plus 4xy plus y square. So this problem also, like a previous problem only, we have to follow the same procedure. So first I'm going to expand the equation by multiplying x minus y. I got u minus v is equal to x cube plus 3x square y minus 3xy square minus y cube. This we got on simplification. So now I'll be differentiating this expression with respect to x partially, treating y constant. So I got dou u by dou x minus dou v by dou x is equal to x cube will become 3x square, x square is 2x, it will become 6xy minus 3y square, x will become 1, y cube is 0. So I got ux minus vx is equal to 3x square plus 6xy minus 3y square. Similarly, differentiating the same expression with respect to y, I'll get dou u by dou y minus dou v by dou y is equal to 3x square plus 0. It will become 0. Since x is a constant, it will become 0 plus 3x square minus 6xy minus 3y square. We got it. So I got the expression like uy minus vy is equal to 3x square minus 6xy minus 3y square. So now I'll be changing this uy and vy in terms of ux and vx by using CR equations. So I'll be replacing uy as minus vx and vy as ux. So I got the expression like minus vx minus ux is equal to 3x square minus 6xy minus 3y square. So I'll be calling this expression as equation number 1 and this one as equation number 2, and I'm going to add this equation number 1 with 2. So if I add 1 with 2, this ux and this minus ux gets cancelled. I can cancel plus 6xy and minus 6xy. So I'll be having minus 2vx is equal to 6 times of x square minus y square, or vx is equal to I'll be having 3 times of v square minus x square. Similarly, if I subtract this expression with this expression, I'll be having this vx gets cancelled, 3x square gets cancelled, 3y square gets cancelled. I'll be having 2ux is equal to 12xy and ux is equal to 6xy. So once we got the value of ux and vx, I'm going to take the formula now. That is f dash of z is equal to we have ux plus ivx. In the place of ux I'm putting 6xy. In the place of vx I'm putting 3y square minus x square. So now I'll put x is equal to z, y is equal to 0. If I replace that value, the 6xy will become 0 plus I times of 3 into 0 minus z square. So I got f dash of z is equal to minus 3iz square. After integration, the value of f of z will become z square is z cube by 3. 3 gets cancelled. I got minus I cube z plus c. Next one, important derivation, that is if f of z is analytic, show that dou square by dou x square plus dou square by dou y square into mod of f of z whole square is equal to 4 times of f dash of z whole square. Proof. Since they have given that the function f of z is equal to u plus iv is analytic, so I can make use of CR equations here, and I can make use of the harmonic property also. So now I'm going to consider the mod of f of z. We know that already f of z is given by u plus iv. If I apply mod for this equation, I'll be having mod of f of z is equal to mod of u plus iv. The mod of u plus iv can be expanded like square root of u square plus v square. So I got mod f of z is equal to square root of u square plus v square. I can do squaring on both sides. I got mod f of z whole square is equal to u square plus v square. I'm going to treat this as some constant c. So now what I will do means I'm going to assume that this u square plus v square is equal to some function pi, and I'm going to prove that dou square by dou x square plus dou square by dou y square into pi. I mean in the place of mod f of z whole square, I'm going to replace pi. So I need to prove that dou square pi by dou x square plus dou square pi by dou y square is equal to 4 times of f dash of z whole square. So now I'm going to consider pi is equal to u square plus v square, and I'm going to differentiate this equation partially with respect to x 2 times. So if I differentiate for first time, I'll be having pi x or dou pi by dou x is equal to u square will become 2u, and differentiating u I'll be getting dou u by dou x. Similarly, plus v square will become 2v into vx. So in simple way we can write like pi x is equal to 2u ux plus 2v vx. Similarly, if I differentiate this function pi with respect to y, I'll be getting pi y is equal to 2u dou u by dou y plus 2v dou v by dou y. Now The next step is I'm going to differentiate this expression again with respect to x partially. Since here I'm having two functions in each cases, I'm going to use product rule. So since 2 is a constant, I'm taking 2 outside. So first I'm keeping u as it is, differentiating ux, I'll be getting u double x, plus keeping ux as it is, differentiating u, I'll be getting one more ux. Same thing here also. Keeping 2 as it is, keeping v as it is, differentiating v, I'll get v double x. Next, keeping 2 and vx as it is, differentiating v, will be getting v double x. So I got the pi double x, or dou square pi by dou x square is equal to 2 times of u double x plus ux square plus v double x plus vx square. In the same way, the differentiating the previous equation, pi is equal to u square plus v square for 2 times, I'll be having pi double y is equal to 2 times of u double y plus uy square plus vy plus vy square. I'll be calling this as equation number 1 and this one as equation number 2. Now what I will do means I'm going to combine pi double x plus pi double y. I mean, to get the expression dou square pi by dou x square plus dou square pi by dou y square, I'm going to combine the equation number 1 and 2. I mean, I will be adding the equation number 1 and 2. So if I add the equation 1 and 2, what I will get? I'll be getting pi double x plus pi double y. Since 2 is common here, I can take 2 common factors. So or we can write like this also. Taking 2 common factor, I'll be writing u double x plus ux square plus v double x plus vx square plus u double y plus uy square plus v double y plus vy square. From these two equations, I can take u common factor. From these two, I can take v common factor. So I got 2 times of u double x plus u double y plus v into v double x plus v double y plus ux square plus vx square plus uy square plus vy square. So since the function f of z is equal to u plus iv is analytic, u and v are harmonic also. So that I can replace u double x plus u double y is equal to 0 and v double x plus v double y is equal to 0. So this function will become 0. And to change this uy and vy in terms of ux and vx, I am going to use CR equation. That I will be replacing ux as vy and vx as minus uy. So now, after replacing the CR equations, I got the expression like pi double x plus pi double y is equal to 2 times of u into 0 plus v into 0. This is because of harmonic property, plus ux square plus vx square plus minus of vx whole square plus ux square. Since these all are same, I can write this one as 2 times of 2ux square plus 2vx square. Taking 2 common factor, I got dou square pi by dou x square plus dou square pi by dou y square is equal to 4 times of ux square plus vx square. I'll be calling this as equation number 4. Now I'm going to consider f dash of z is equal to ux plus ivx. So I'm going to apply mod on both the sides for this equation. If I apply modulus, I'll be getting the equation like mod f dash of z is equal to mod of ux plus ivx, and expanding modulus, I'll be getting square root of ux square plus vx square. So squaring on both sides, I'll be getting f dash of z square whole square equal ux square plus vx square. Now I can replace this expression in this place. So I'll be getting dou square pi by dou x square plus dou square pi by dou y square is equal to 4 times of f dash of z whole square. This is the required proof what we need to prove for this problem. One more example. If f of z is a regular function of z, show that dou by dou x of mod f of z whole square plus dou by dou y of mod f of z whole square is equal to mod f dash of z whole square. So same in this problem also, I'll be assuming some function mod f of z as pi and I'm going to differentiate that. So since the function f of z is equal to u plus iv be a regular function, so we can make use of the CR equations as well as harmonic property here also if it is unified. So now I'm taking f of z is equal to u plus iv. So for this function, I'm going to apply mod on both the sides. So if I apply mod on both the sides, I'll be getting mod f of z is equal to mod of u plus iv, or mod f of z is equal to square root of u square plus v square. I'll be treating this function as pi. So actually we need to prove that dou pi by dou x whole square plus dou pi by dou y whole square is equal to mod f dash of z whole square. Since I'm treating pi as mod f of z here, so I can make use of this equation. So now what I will do means, I'm going to take pi is equal to square root of u square plus v square, and I'm going to find the partial derivatives dou pi by dou x and dou pi by dou y. So now I'm going to assume pi square is equal to u square plus v square by squaring on both sides for this equation to make the equation very simple. So I'm making this like this, pi square is equal to u square plus v square, and I'm going to differentiate this equation with respect to x and y one time. Suppose if I differentiate this expression with respect to x one time, I'll be getting 2 pi x. So pi square will become 2 pi, and solving pi I'll be getting pi x. Similarly for u square also, it will become 2u ux, 2v vx, and I'm going to divide the entire equation by 2. I got pi x is equal to u ux plus v vx. Similarly, differentiating the same expression with respect to pi y, I'll be getting 2 pi y is equal to 2u uy plus 2v vy. And same dividing the equation with 2, I'll be getting pi y is equal to u uy plus v vy. I'll be calling this as equation number 2 and this as equation number 1. So since now I'm going to square and add both the expressions. So squaring this expression and squaring this expression and adding with this. So I'll be getting pi square pi x square plus pi square pi y square is equal to u ux plus v vx whole square plus u uy plus v vy whole square. I'm taking pi square common factor. I got pi x square plus pi y square is equal to u ux plus v vx whole square plus u uy plus v vy whole square. Expanding this expansion by using a plus b whole square formula, we'll be having u square ux square plus v square vx square plus 2u v ux vx plus u square uy square plus v square vy square plus 2u uy vy. So now I'm going to group the terms. So I got the since the function f of z is equal to u plus iv, I can make use of CR equations. I'll be replacing all uy terms by minus vx and all vy terms by ux. So now the expression leads to pi square pi x whole square plus pi y whole square is equal to u square ux square plus v square vx square plus 2u v ux vx, u square uy square plus v square vy square plus 2u v uy vy. So in the place of uy vy and uy vy, I'm replacing u as minus vx and vy as ux. So I got expression like u square ux square plus vx square, v square plus ux square vx square. So like after replacing uy as v minus vx and vy as ux, I can take u square v square common factor and I can group the terms like this. And this 2u v ux vx and it will become minus 2u v ux vx. I can cancel that. So from this one, I'm taking ux square plus vx square into u square plus v square common factor. I got expression like this. So I got pi square into pi x square plus pi y square is equal to ux square plus vx square into u square plus v square. Since we know that I assumed like pi square is equal to u square plus v square, I'm going to replace this here. So I got expression like pi square is equal to pi x square plus pi y square is equal to pi square ux square plus vx square, or pi x square plus pi y square is equal to ux square plus vx square. So I can cancel pi here. I got this expression. So now I'm going to assume the equation f dash of z. So we have f dash of z is equal to ux plus ivx. Applying mod on both the sides, I'll be getting mod f dash of z is equal to mod of ux plus ivx. So it will become f dash of z is equal to square root of ux square plus vx square, or mod f dash of z whole square is equal to ux square plus vx square. I can replace this value in the previous equation here. I can put here. So I got expression like pi square plus pi y square is equal to mod f dash of z whole square. So these are required proof what we need to prove in this problem. Okay, in the next lecture video, we'll discuss a few more problems on other types, type 1, type 2, type 3 and type 4. Thank you.